In today's video, I want to talk about something relating multidimensional arrays. So here we have a 2D array, and what I want to take a look at is how to do operations based on the neighbors of a certain element inside the array. So for example, here we can have this element, and let's say we want to sum up all the digits around it and itself. So what I want to get really is the sum 1 plus 2 plus 3 plus 2 and plus 2 here. So I want the result of that. How do we programmatically do that? Especially if we want to, for example, read the position of this element. So I want it to either to be here or to be here. Either way, it should actually sum it up in a cross, for example. How can we do that? Well, first let's just read the x and y that we're going to actually use. Just like so, so just simple 2 printfs and 2 scanf underscore s I'm using, but you can use it just the regular scanf, that's fine. And now what I want is these two are going to represent that that position here, for example, and I want that those neighbors. How do we get that? Well, we have to take a look at offsets compared to the main point. So the main point is this guy, and I want to get all the offsets for every single neighbor here. Those offsets are going to be stored inside two arrays. So here we're going to have here int offset for the x-axis, right? And it's going to have some values, and of course another one for the y-axis. And I didn't tell you this, but for the x-axis is from left to right, and the y-axis is from top to bottom, right? So if we have, for example, the position, let's say 1, 2, well, it's 1 on x, so it's going to be one of these, and it's 2 on y, so it's going to be this guy. Right, so this is going to be position 1, 2. So if we have this position 1, 2, what we want is to get the position, the offsets between it and all its neighbors. So for example, if I want to take a look at the top neighbor, well, its position is 1, 1, right? Well, what's the offset between this and this? Basically, what's the difference between the two? Well, 1 minus 1, so this one from the right minus this one from the left is 0. So for x, there's no difference, right? Because we're just looking top and bottom. And 1 minus 2 is negative 1 in this case. So we're just going up. That's what negative 1 means. And we do the same for all the neighbors that we want to have in here defined. So here this is the neighbor, then the next one would be this guy. Well, this guy has the coordinates 2, 2 here. So I'm going to have here 2 minus 1. That's 1. Okay, and we're going to have 2 minus 2, which should be 0, of course. And then the one at the bottom, well, what coordinate does it have? Well, it has the coordinate 1 for x and the coordinate 3 for y. So in this case, we're going to have 0 difference on x and 1 difference. 3 minus 2 is going to be 1. And then the last one is going to be negative 1 here and 0. As you can see, they kind of have a repeating pattern here. It goes 0, 1, 0, negative 1, negative 1, 0, 1, 0. Okay, so now how do we make use of these? Well, we can simply iterate over all of them and get each neighbor individually. So here we can say for, so let's actually initialize here an I. So int I and then a for loop that goes from 0 to 4, because there are 4 offsets, right? 4 neighbors. So this I really represents a neighbor. And what we have to do in here is basically apply the offsets to the main coordinate. Well, the main coordinate is going to be on x or on y. Okay, so for x, well, I'm going to define here another coordinate for the neighbor this time. So int nx from neighbor x position. And that's going to be x plus the offset in the x-axis for the ith neighbor. Okay, I hope this is clear what this means. And similarly for ny, so y plus offset of I, offset y of I, like that. And now that we have the coordinates, we can just say array of ny of nx. We do have to type them in the reverse order because, well, the first coordinate, the first index is always going to select the one of these arrays, right? So if I say array of, let's say 3, it's just going to select this array, right? So this means really the height, so from top to bottom. So then in the second coordinate means that we're going to go inside this array and select a number, basically from left to right. So in this case, this is going to be the value of our neighbor, of each of our neighbors. And then what we have to do is just sum them all up. So here I can start with a sum variable that's going to be initialized with the value in the middle, because I also want that in the calculations. So here sum equals array of y of x. That's very important. The order the order has to be the same here. We're just going to say sum plus equals that. And then what we have to do is just say printf the sum is %d. And then if we type in here the sum and then run this, we should get a proper result if I input the proper variable. So here, if I say I want 1 and 2, which was this guy, well, this is how much? So this is 1 plus 2, that's 3, plus 3, that's 6, plus 2, that's 8, and plus 2, that's 10. So we should be getting 10 in this case. If I have here the x coordinate should be 1 and the y coordinate is going to be 2, and as you can see the sum is 10. So that worked nicely. The biggest issue with the code here is that we don't check for any bounds, right? So if I run this again and I, for example, want to sum all the neighbors from this corner here, right? So if I say here 0, 0, as you can see, I'm just going to get some weird number because we have actually iterated over 4 neighbors, but we only have 2 neighbors in this time, right? We only have this guy and this guy. So we have to really treat that case. To do that, it's very simple. We just have to place in a condition saying if n of x is, well, less than 0, then we don't care about it, or n of x is higher than, in our case, it's 5. That's the number of our matrix. That's the size of our matrix, so 5 by 5, but your mileage may vary. Or if ny is less than 0, or if ny is higher than 5, actually higher than 4 in this case. If any of that is true, then we can just continue. And continue, what it does is just skips over this line of code in our case. So it's not going to sum it up. So if I say here 0, 0, as you can see, the sum is 4. And I think that is correct because 1 plus 1 plus 2 gets us 4. And if we, for example, say, let's say 4 and 4, we get 14 because we selected this corner and we have 5 plus 5 plus 4. That's 14. Okay, so that's very nice. Now, one thing that I want to take a look at is what if I want to change the neighbors? What if I want a larger set of neighbors? What if I want also the diagonals to be added? So if I, for example, start with this number, I want all these around me, this, and this to be summed all up. How can I do that? Well, very simple. We have to just change the offsets here. So instead of just having these 4 numbers, we're going to have 8 numbers, because there are going to be 8 neighbors all around us. So in our case, if I start from the top, so this was, the first one is the top guy, right? And then I can add the one from the diagonal right here, which should have the offset. Well, on X, it has the offset 1, right? And on Y, it has the offset -1. Okay? And next up was this guy. This is this one from the right. Then from the right bottom is going to be, well, on X is again 1. Okay. But on Y, it's actually again also 1. Okay, because we go down this way. And then we have this guy, which was this guy, 0, 1. So 0 on X, 1 on Y, that goes down. And then left bottom, that should be on X, we should go once -1. So once to the left, and then once to the bottom. So 1 here. So we got this one, and then we have the left neighbor, which was our last neighbor here, -1, 0, right? And then we have the left top one, which is -1, -1, right? Because we go up, so that means -1 on Y, and we go left, that means -1 on X. So there we go. And as you can see, there's another pattern here. You can see that 1 repeats here 3 times, here 3 times, and -1 actually repeats here 3 times, and as well on the Y offset, except it just kind of sort of wraps around. Only if you wrap around, it repeats 3 times. It's very simple to memorize once you do it once or twice. But this is the offset. These are the offset arrays. And now if I actually change the number of neighbors we iterate over, so now we have 8 neighbors. And if I run this, if I say I want the neighbors of 1, 2, I want them to be summed up. Well, it's 18. And we selected this guy. So the sum should be 1 plus 2 plus 3. This is 6 and 3 times. So that should be 18. And this is what we got, right? 18. And of course, this also works if you are on a corner or something like that. So if I have, for example, 0 and 1, I'm just gonna get 9 because I only have a few neighbors, like I think 5, yes. So it was just 1 plus 2, so 3 times 3. And really, this is a pretty legible solution for this problem, for this iteration of neighbors, because the nice part about it is you have some arrays, so you have some memory usage, but you only have one for loop. And you don't have to deal with multiple for loops and whatnot. Sure, you could have done it with just 2 for loops and then iterated over in a square pattern in this case, but in the other case where we had only 4 neighbors, not so much. And especially if you want to change the neighbors, this is pretty easy, and if you don't have too many neighbors, of course. And this can be expanded to multiple dimensions. So if you have 3 dimensions, you can have another offset of z here and just add the same amount of offsets here, and you are good to go, really. Just make sure, so once you have calculated the offsets, just make sure you actually validate the data, because you might get some out of bounds indices, and that won't be great. So just kind of ignore them and then sum them all up. That's really all there is to it. I hope you got something out of this video. If you do have any questions, do leave them down in the comments below or on our Discord server. Take care. Bye.